What's up, stats? This is C-Squared Mathematics. I'm Mr. Carlson. We are going to be learning 4.2 binomial distributions. So we are still in our probability distributions week. We're still doing that, discrete probability distributions. So this is one of the probability distributions that you will be learning, not just the basic kind, but it's literally called binomial distribution. So there's a big formula to it. We're going to discuss that formula. We're going to go into the distribution. We're going to be using Desmos a lot. And then, of course, going through example over example over an example. So hopefully that will help you understand a little bit more about distributions and prepare you for tomorrow when we learn two more. So bell work, homework quiz for 4.1. And then we're going to get through the lesson. So these are the two questions I have for Bellwork. These will be on the homework quiz. So let's get started. Make sure you take a picture, write them down. The second one, I am going to be using the 4-point this distribution list that I showed you yesterday during the video. I will be using that during the second question. But this first question, let's get started because this first question, we don't need anything. We don't need any calculator. Okay, the number of textbook authors now sitting at a computer. Well, can you have half of an author? No, so this is discrete. I'm going to put D there. Okay. B, the number of people in a restaurant that has a capacity of 300. Okay, well, that's also discrete because you can't have half a person. The amount of rain in city B during April, that's continuous because it could be like 0.25 inches, or it could be 10.76 inches. It could be a continuous random variable instead of a discrete random variable. So the number of light bulbs that burn out in the next week, if with 16 bulbs, well, 16 kind of gives it away. That's also discrete because there's not 16 point something. It's not a fraction. It's a whole number. And the weight of a T-bone steak, the weight, of course, can be 10.78 or it could be 5.87. It could be a fraction, so that means it's going to be continuous. And that's that simple, guys. It's that simple when you go through each one of these and figure out whether or not it's continuous or discrete. Now, this second one, it has a lot of parts, so try to keep up. Okay, so A is going to be the mean. Then it's going to ask for the variance, standard deviation. It's going to ask for the expected value, which is the same thing as the mean. And then it's going to interpret the results. Okay, so now what is this? This is actually the graph right here. Okay, what this is our actual probability. So these numbers right here is the actual probability that I'm going to be plugging in. So I'm going to plug in all of these numbers into my probability distribution from Desmos. And I'll be using these numbers on the bottom for my x. So this is my x down here, and these are my probabilities. Okay? So let's get started. My first one is 0.267. So I'm going to go over here. I'm going to change this. I'm going to delete this whole fraction and do 0.267. Great. Next one is 0.326. So I'm going to go over here. 0.326, 0.326. Okay. Next one is 0.164. So go down, 0.164. 0.151. Go down, 0.151. I have 0.065, so go down 0.065. And I'm still going to go down, even though it doesn't give me an option, I can still kind of click on the next one if I needed to. So make sure you know that. You can click on the next one and add to the table if you need to. So add to the table, and then this is 0.027. So 0.027. Now, let's go to our x values. I want to change these to the x values I have here. 1, 2, 3, 4, 5, 6. So I'm going to change this to 1. This is 2, 3, 4, 5, 6. Now everything else changes. Now that I have this, I want to see if I actually put it in correctly. Is it a probability distribution? It is. It equals to 1. So solid, I can erase that. Now the first thing it wants to know is my mean, okay? My mean, then the variance and standard deviation and expected value. So we're going to go through all of that. And I'm going to just stay on Desmos. So you're going to copy down the answers on Desmos here, okay? Mean, variance, standard deviation. And then we'll come back, we'll erase, and we'll get started with the lesson. So what's my mean? I click on this. Okay, my mean is this right here. I don't know what they want, like what decimal place they want you to round to. Just, I would probably write down the whole thing. But now notice, I need to change this to match. So I need to put 2.502. I need to make sure I change that to match. So now notice everything else changes. So now my variance will be updated. My standard deviation will be updated. And then, of course, my expected value is this. So my A, what's my A? It is 2.502. Okay, that's my A value. That's my mean right here. That's my mean. Write it down. That's my mean. That's your first answer. Mean A value. What is your expected value? I'm going to jump to D here. Your expected value, again, is the same thing as the mean. So whatever you put for your mean, it is the exact same thing. So what's your expected value? This, 2.502. That's what it is. Okay? So you already have the mean. You already have the expected value. Awesome. Let's continue. So now my variance is this. 1.7999, so probably 1.8. So I'm going to say variance equals, let's do 1.80. That'll probably be easier. And then now I can scroll down to my standard deviation. My standard deviation is 1.34. Okay, so I'll say that. So my standard deviation is 1.34. So this is my mean, and it's also my E of x. Okay, it's also my E of x. This is my variance. This is my standard deviation. Done. Did it ask for fair price at all? No. Okay, it didn't. I'm just going to leave it at that. Now, my last thing that they ask is interpret the results. So interpret the results is my expected value is literally the exact same thing as my mean. We have an average of about 2.5 to 3 household members, so household sizes. So it's roughly around 2 to 3 is my average size. Okay, around 2 to 3 is my average expected size. That's what the interpret the results would be. That's for E. Okay, awesome. So that is how you do 4.1. I hope I didn't go through it that too quick. I'm going to erase. Again, it's going through just your standard deviation, variance. Make sure you're changing that value, okay? And then make sure you are adjusting only these values. You don't need to do anything with those. Those are already adjustable. Those are not adjustable, okay? You can't adjust those. Okay? Sweet. Awesome. All right, so let's erase. Let's get you started on your homework quiz. It's going to be 5 questions. 5 questions, 25 minutes. Make sure you use your notes. Okay, especially if you've written down the notes, make sure you use them. Take your time, but please review your answers. There's a lot of partial credit with regards to this. If you didn't round correctly, or you maybe forgot a decimal, or you fat fingered a 6 or something, then please let me know so I can actually go back and adjust that for you. So please send any partial credit requests. Get started on 4.2. Print out the notes from Google Classroom, and then we are going to begin. Okay, so hopefully this video is not as long as the last one because I don't need to explain as many things about the probability. And since you know that I'm going to be using Desmos, this Desmos one that I'm going to be using will look like this. Okay, this is the new Desmos link. How do I find that? If you go to classwork on Google Classroom and then you scroll down to probability, you'll see something called, right underneath the 4.1 probability distributions, you will see something like this. Okay. And what that will say is just the distributions all or complete, and basically a list of all of the distributions that we're going to be going through. So it will look like this. Now, this one, and this one are what we call discrete probability distributions. Okay, that's what we're going to be doing this week. Today it's just going to be this one, binomial, and then tomorrow it's going to be geometric and Poisson. Yes, I say Poisson. It's French. Okay, we'll describe it tomorrow. This is what we call the normal distribution, is what we call the continuous probability distribution, and that's going to be literally all next week. we're going to be spending almost 2 weeks on that because it's very, very important. So that's a really big topic in statistics, probably like the topmost topic in statistics. As the quadratic is to algebra, the normal distribution is to statistics, okay? So just this today, though, binomial distribution, make sure you grab that link right there, click on it, save it to your account so it's saved. Let's get started. How do I find probability using binomial distributions? So this is another link. You can click on that. That's the crash course video link. She goes over the binomial distributions. It's actually really entertaining. I really encourage you to at least maybe spend some minutes on watching that. I'm not going to do it right here for the sake of time. Let's get right into the actual definition. What is it? A binomial experiment is a probability experiment that satisfies the following conditions. And there's four. There's four conditions. Number one, the experiment has a fixed number of trials where each trial is independent of all the other trials. The experiment has a fixed number of trials where each trial is independent of the other trials. There are only two possible outcomes of interest for each trial. Each outcome can be either classified as success, or S, or failure. Okay? And then the probability of success, the probability S, is the same for each trial. So the random variable X counts the number of successful trials. So what is happening here? Actually, a lot of stuff is happening here. So I'll try to make it very simple and short for you. We can make a binomial distribution, a binomial experiment. Let's just say by basketball. So if I shoot a basketball, okay, there are two possible outcomes. I can either make the basket or not make the basket. In each basket, there's a fixed number of trials. Let's just say there's 10 I'm going to shoot, or actually just a free throw. So let's just say there's 2 free throws, right? 2 free throws that you get if you get fouled in basketball, correct? 2 free throws if you get hit, if you get fouled in basketball. Okay, those 2 fixed number of trials, there's still 2 possible outcomes, success or failure. I mean, that's just you can either make the basket or not. The probability of success is the same for each trial. So in that case, it would just be like 0.5, or if you're really good, if your actual probability of making a basket, like if you're LeBron James or Michael Jordan, is probably higher. And then the random variable X counts for the number of successful trials. Okay, so let's actually get to what the notation is. What does the notation look like? And you're going to be writing all this down. So I'm going to give you symbols and then descriptions. In symbols, it's N. That just means the number of trials. So N just means the number of trials. Now P will equal the probability of success, and that's going to be the probability of success for a single trial. I'm going to be using Q, which will be the probability of failure. The probability of failure in a single trial, which is obviously the complement of success. If I fail, that means I'm not successful. Okay, so if I am successful 75% of the time, that means I failed the other 25% of the time to make 100%. And then right here, I have X, and X is the random variable represents a count of the number of successes in trials. So 0, 1, 2, 3, all the way to the number of trials I'm interested in. So if I have only 2 free throws, okay, I could do 0 free throws, I could do 1 free throw, or I can do 2 free throws. I can make them both, or I could fail on both or not. So think about that. Let's move on. That's the notation. That's the binomial notation and the descriptions. Let's actually do a couple of examples, 3 actually to be exact, on how to identify a binomial experiment. So decide whether the experiment is a binomial, and then if it is, we're going to label these answers N, P, Q, so forth. Okay. A certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. Okay. The random variable represents the number of successful surgeries. So first of all, we have to look at our definition. Okay, we have to look at our definition. Is there like one trial? Well, yeah, there's one thing that's actually kind of going. There's one trial. There's, as in like by one trial, there's one thing that's actually the case, and that is just this certain surgical procedure. Now, I will have 8 patients, so that means 8 independent trials, okay? And then I have 2 outcomes. Is it either successful or is it failure? So I'm going to say that this is, yes, a binomial experiment because, number one, it has one trial. One trials, that doesn't make sense. One trial. One procedure, as it were. 2, it has 8 independent trials with patients. Okay? And then 3, it has 2 outcomes. So this is what it means to be binomial. Remember, bi means 2. Okay, so that means 2 outcomes. That's why we call it a binomial experiment. If it doesn't have 2 outcomes, then it's not a binomial experiment. So if it's 2 outcomes, binomial experiment. Now, my second step is now to actually label out all my variables. So what is my n? What is my p? What is my q? Okay, and then what would be my x? So what is my n? Well, my n will be 8 because that's the total number of trials. My p, my probability of success is 0.85 or 85%. My q is the complement of that. So this actually equals 0.15. And then my x is a lot. It's actually 0, and then 1, 2, 3, 4, 5, 6, 7, and then 8. So it's all 8 of those trials. 1, 2, 3, 4, 5, 6, 7, 8, and then including 0. Okay, so this is how a binomial experiment sort of looks. The best thing that we need to do is just say, okay, is it a binomial experiment? Then we can start labeling our actual variables. So let's do another practice run. A jar contains 5 marbles, 5 red marbles to be exact, 9 blue marbles, and 6 green. You randomly select the 3 marbles from the jar without replacement. So this is the key part. Without replacement, the random variable represents the number of red marbles. This tells me automatically that it's dependent because that means the marbles, since I don't replace them, I take them out of the jar and leave them be. Okay, that means my total is changing. My probability is changing. Since my probability is changing, it's no longer independent. If it's no longer independent, that means it's dependent. If it's dependent, it is not a binomial. Okay, it's not a binomial experiment. Okay, so that is my answer, not a binomial experiment. Okay, the probability of success is not the same for each trial. The probability of success, because the total has changed, the probability of success is not the same for each trial. Okay. Now, this one. You take a multiple choice quiz. Contains 10 questions. Each question has 4 possible answers. Only one of which is correct, of course. So you can either get it correct or not correct. So let's start labeling stuff here. So in the trial here, we can answer the question. That's really what we're doing. We're trying to answer the question. So, okay, that's nice. We have a trial. Now, we do have some success in answering the question correctly. So you can either have success or you can fail. Okay, and that's also true. So both of these are true. You can randomly guess the answer to each question. Random variable represents the number of correct answers. So because this is true, there's 2 outcomes, and there is a specific trial in mind answering the questions. This is yes, it is a binomial experiment. Now 2, we're going to be actually labeling our variables. So we're going to start with n. We're going to go to p, my probability of success, q, failure, and then x. Now, what's n? Well, n is the total number of trials. So how many total number of questions? 10. P, what's the probability of success? This one's a little bit harder. If there's 4 possible answers, what's the probability of getting one of the answers? Well, there's 1 correct answer, so that means 0.25, which means chance of failure is 75. And then my n starts with 0 always, and then 1. 2, 3, 4, all the way to 9 and then 10. So it goes all the way through 10, 0 through 10. Okay? So that is how you do a binomial, identify a binomial experiment. Let's actually get to the probability formula. And then after that, we're going to start using technology over and over and over and over and over again. Okay? So let's erase. So here's going to be the formula. I love Dwight Schrute. Give me some Schrute-ness. In a binomial experiment, the probability of exactly X successes in trials is this right here. Hold on to your hats. The probability of X equals NCX. Something that should look very familiar. Times, because that's what multiplication means, the dot times P to the X power times Q to the N minus X power. Okay? This also can equal, okay, N factorial all over N minus X factorial times X factorial times P to the X power times Q to the N minus X. Now, which one am I actually going to use? I'm really going to use this one. And we're actually only going to do this a couple of times by hand, and that's it. We're only going to do it a couple of times by hand. That is it. Because most of the time, we're going to be using the calculator, and the calculator I'm going to show you on Desmos over here is going to do all the work. I still want to show you how to do it by hand with some examples. Okay? This should be very familiar, though. This is our combination formula. So right there, that's our actual combination formula from a couple of weeks ago. Okay? Actually, just last week. It's last week, 3.4. So combination, that comes from 3.4. Okay, combination formula. Now this is just a reiteration of what that is. Remember this right here is the same thing as the combination formula. We just never do it by hand, right? We do it on the calculator. Okay, there's a long way to do it on the calculator. There's and there's an easy way to do it on the calculator. I'm going to show you just a couple of examples of the long way how to do it on the calculator. And then we're going to do it the easy way, okay? So note that the number of failures is N minus X. The number of failures is N minus X. So right here. So it's Q and then the number of failures. It's N minus X. That's not really that important. So let's erase and let's kind of do this by hand. Rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. So you do have one trial and it's the surgery. Okay, and then you have 3 independent trials within that trial, and that is the N. Okay, and then you have success or failure. So you do have certain amounts of 2 outcomes. You have 2 outcomes here. Okay? Awesome. Now, let's go to the first step. Let's list out our variables. What is N? What is P? What is Q? And then what is my X here? Okay? Awesome. Now, rotator cuff surgery has a 90% chance of success. Well, that seems like my Q here, so I'm going to put 90, which means my P, and I'm going to put 90, 0.9, and then 0.1 is my Q, my complement of failure. Performed on 3 patients, so there's a total of 3 patients. Okay? And now, what is my X? Find the probability of being successful on exactly 2 patients. What is that? So exactly 2 patients. I'm not going to include 0, 1, 2, 3. So I could say 0, 1, 2, 3. But since I want exactly 2 patients, I'm actually going to pinpoint that 2 here. So I really don't care about the 3, the 1, and the 0. I only want the 2. Okay, because I want exactly 2 patients. Okay, now how do I put this? I do the probability of 2 equals, following my formula, I have my N is 3, C, because that's combination, and then 2 is my X, times my probability of success is 0.90 to my X power, which is 2, times, and then 0.10 is my failure, to the power of 3 minus 2. Okay? Now, I am going to do this on the calculator. I'm going to go to Desmos right now. I'm going to show you how to do this. Now, again, we're only going to do 1 or 2 examples of this by hand. This is a long way how to do it on the calculator. But this is how you would do it. So let's go to a new thing right here. Let's start typing it in, shall we? So I have NCR, okay? And I'm going to actually type in 3, 2. Okay? I think that's NCR. Give me a second. I should definitely, yeah. Okay, let's just begin then. This is going to be multiplied by 0.9, and then all to the power of 2. And it's going to be multiplied by 0.1, all to the power of 3 minus 2. Now notice how I'm putting parentheses around that. Okay, so this should definitely calculate it. What if I do m equals? Will that do anything? Will that do anything at all? That is not doing anything at all. Okay, I actually went back and I'm not going to actually type it in here. Okay, I'm going to type it in just a brand new one, and then I get this, and that is my answer right here. So I just typed in a brand new Desmos link, and that's fine. So my answer is 0.243. So I go back here. So 0.243. That is my probability of 2. This is the probability of selecting 2 given this binomial experiment. So that's not too bad, right? I don't think it's too bad. So let's continue on to another example. Okay, a card is selected from a standard deck and then replaced, so it's still independent. That's awesome. It's not changing my totals at all, the success or anything. The experiment is repeated a total of 5 times. So my n has to be 5. Okay, find the success, the probability of, not success, find the probability of selecting exactly 3 clubs. So that means my P and my Q are going to be a little bit harder to find, but I know my X is 3 because I want exactly 3 clubs. Now, what's the probability of selecting a club? That's the first thing I need to find. Well, how many suits are there? There's 4 suits. And then how many, there's 4 suits. And so that means in the standard deck of 52 cards, there's 4 suits. If I want to select a club, that means I need one of those 4. One of those 4 is the same thing as 1/4. 1/4 is 0.25, which means not selecting a club is 0.75. Okay, so what this will look like now, after I listed it all out, that's my first step. After I listed it all out, my second step is the probability of 3, exactly 3, equals 5C3, then times 0.25 to the 3rd power times 0.75 to the 5 minus 3. Okay, let's go back, adjust our totals here. So I'm going to adjust these. So I want 5 and 3, so 5 and then comma 3. And I scroll over. I don't want 0.9, I want 0.25. That's my probability of success. I don't want that. I do want 3. I don't want this. I want 75. And then I need to make sure that this is 5. And that is 3. So my answer is 0.087 or 0.088. That is my answer. 0.088. So about 8%. Awesome. That is how I do a probability distribution. Not distribution. Just straight up finding one probability. We will be doing distributions next. So before we get there, I'm gonna I guess actually let's just do that next. So let's erase. I actually want to do this. I'm not going to go through this whole example, but I guess since I said, yeah, let's do probability distributions. Now this is how you actually construct a probability distribution. I do like this example, but I'm not going to go through all of it because it's very long. In a survey, U.S. adults were asked to give reasons why they like texting on their cellular phones, cell phones. The results are shown in the graph right here. 7 adults who participated in the survey are randomly selected and asked whether they like texting. Okay, so 7. So think about that, 7. Whether they like texting and asked whether they like texting because it's quicker than calling. So look at this, quicker than calling down here. Okay? Create a binomial distribution for the number of adults who respond yes, they do think it's better than quicker than calling or whatever. Okay, so I'm only going to do a couple of these, but I'm going to show you what it will look like. When I want to make a distribution, I have to do the whole thing. So what I just did before was I just did a couple of probability things. I didn't actually do a whole chart. Now you would make a chart. Now the chart's already done here. Isn't that nice? This is the chart technically, like it's already completed. Okay, this is the chart. I'm going to show you how we got that chart. So we start with probability of 0. Now notice it goes to 7, right? Because it's 7 adults. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. And of course, it's probability equals 1 because this is a probability distribution. And now we're going to be doing this binomial distribution, and we're going to try to replicate this. It's already completed. It's right there. It's already completed. But now what we're going to do is try to replicate it by using what we did in the last slide. So what does that look like? Probability of 0 equals, okay, 7, C, 0. Why? Because it's 0 right here. That's why. Okay, times. What is the probability of success? Well, the success is right here, 56, okay, 56. So that means 0.56, and then to the 0 power, times the complement, which is 44, because 0.56 plus 0.44 is 1. So that's a complement. And then this is going to be 7 minus 0. What this gives me approximately is 0.0032. But this is exactly what we got right there. Okay? That's exactly what we got right there. And that's how I would do it. So if I wanted to do the probability 1, this would be 7C1 times, it would be 0.56, and then 1 times 0.44, and then this would be 7 minus 1, and this would equal 0.0284. And this is exactly what we have right there. And then, of course, if I wanted to do the probability of 7 at the very end, I'm not going to do everything else. Okay? I'll erase that. Just give me a second. So if it continues, probability of 7 is 7C7. And I could plug all this in the calculator, guys. That's how I could get this. Okay, so 0.56, and then this is 7, and then times 0.44. This is 7 minus 7, and then this equals, what does this equal? Well, it equals 0.0173. Okay? So this is how you would do it. This is how you would actually construct the probability distribution. We're not really going to be constructing probability distributions. Like I'm not going to actually construct it for you. But this is how it would be. Maybe on your homework, you'll probably be asked to do exactly 1 or exactly 2. But I'm going to show you how to do it, not the long way now. I'm going to show you how to do it the easy way, okay? Because all of this you can do on the calculator, not like this. This is not what I mean by on the calculator. I mean using this, okay? And I'm going to show you how to do that now. So let's erase. All right, now using technology, awesome. So finding probabilities, finding binomial probabilities. In example 4, it's going to be asked to do this, okay? The results in a survey, recent survey indicates 0.67 or 67% of U.S. adults consider air conditioning a necessity. Yeah, definitely in Arizona. Okay, you randomly select 100 adults. What is the probability that exactly 75? Exactly, 75 adults consider air conditioning a necessity. So how do I do this? Well, the first thing I do is I need to list out my variables. Okay, so this is my N is of course 100. My P, my probability of success, is 0.67. and then my Q, my probability of failure, would technically be 0.333. Okay, and then what's my X? My X is 75 adults. Now watch what I'm about to do here. I'm going to show you the thing on Desmos. And I'm going to try to use these values that I just written down. I'm going to use those values and I'm going to put them on Desmos. I'm going to show you how to do it. This is important because you will not pass this week. You will not pass the homework quiz. You won't pass the problems on the test this week unless you use Desmos. Do you understand? I hope you do. So save this to your account. Remember, it's in your classwork. Just click on that, save it to your account. Okay, now when I show it, don't freak out. So this is what it looks like. Okay, I just toggled it on. Now you're going to use each individual one for a certain problem. You have to be wise enough and smart enough and pay attention enough to me when you are to use each individual one. Okay, there's a lot of stuff here. Now some you may not be able to use, okay, in any particular problem. So for instance, the problem that we're looking at right now, notice how this says PDF. Okay, and on your notes it will say probability density function, PDF. What does that mean? That means when there's exactly one thing that you're interested in, when it says exactly something, exactly 75, exactly 3, exactly 2, whatever, when it says exactly something, you are going to be using what we call the PDF function right here. Okay? You're going to be using what we call the PDF function right there. Okay? That's what you're going to be using. Okay. So, what is that? So, what I'm going to first do is it's going to be listed out like this. Okay? So, your binomial function, this is what it will look like on Desmos. And you can write this down if you want. It's binomial distribution. What it has is the n trials, comma, my probability of success. And then PDF, and then X. So this is what it will look like on Desmos. And so you literally just put in your n right there, comma, p, and then x. Put in your n right there first, comma, p, then x. N, comma, p, then x. N, comma, p, then x. So right here, that's n, that's your p, this is your x. Now, of course, those aren't the values I want. So what do I have to do? I have to change them. I have to change them. So what do I want? Well, my N was 100. Okay, 100 adults, right? 100 adults. My P was 0.67. That's my probability of success. So 0. I'll even put the 0 here, 0.67. That's my probability of success. And then my X I was interested in is exactly 75. So I go over here and I type in exactly 75. Okay? And that is how I would do it. Okay, so this is my actual answer. Sorry about that. I was just kind of fixing it, but this is my actual answer. So again, to reiterate, this is my N, this is my P, my probability of success, and this is my X. I want exactly 75 adults. So what is my answer? Right here. That is right there. Okay? So I'm going to go back and let's label this out. So what is this? This equals 0.0, 0.0201,004. So this is roughly like 2%. So what's the probability of selecting exactly 75 adults that consider air conditioning a necessity? Okay. Or sorry, it's roughly 20% because 1 and then 2. No, that's definitely 2%. Yeah, it's definitely 2%. Okay. Which seems pretty low. I have to say, like, that seems pretty low. I mean, exactly 75 adults. I guess if you have to have the total. So all 75 adults. What's the probability of selecting 75 adults who actually think it's necessary? Yeah, I guess that makes sense. All right, so that is how you do it. This is the second step, actually plugging into Desmos. Make sure you copy this down because this is how it is. Again, I don't have the N right here, but this is N. This is your Q. Sorry, not your Q, your P. That's your P, your probability of success. Okay, and this right here is your X right here, right? So make sure you just know those things. I could do it so it's a little bit easier for you, or maybe, but I think the more I teach it, the more I think that this is the easiest for you to just change those values. That's all you're doing, guys. You know that, right? Like, you know that all you're doing is literally changing values. That's it. You're just going over here and changing those. That's it. You just need to know when to use one of these. So that's what I'm going to teach you. If it's PDF, if it's exactly something, you're going to use PDF. Okay? So let's erase this. The next one. Survey found that 34% of U.S. adults have hidden purchases from their spouses. Yikes. That's pretty dangerous. You randomly select 200 adults with spouses, and what is the probability of exactly 68% of them? Or sorry, 68, not 68%, but 68 of them have hidden purchases from their spouses. Well, here it is. My N is 200, so I select 200. I have 200 adults. My probability of success is 0.34. And then my X right here is 68. What's the probability of selecting 68 adults with hidden purchases? Okay, so I'm going to use this. Remember, I'm going to plug it in like such. So binomial distribution. Remember that my N comes first, comma, then my success, dot PDF, and then my X value. Okay, remember that. Okay, remember that. And so then I'm going to get an equals, and we're going to solve it. Now, we could do this by hand, right? Remember, we could definitely do this by hand. We could do this by saying N, or sorry, by saying it completely by hand, by doing the probability of 68. And then this would be 200, and then C, 68. And then I could do 0.34 to the 68 power, and then times my complement, which is 0.66, and then to the 200 minus 68 power. So I could type this in. I could literally type that into Desmos. This is the long way to do it. Right here, what I'm doing. I could do this. Okay, remember, we did it just a couple slides ago. But the easier way, so you don't have to do all of this, the easier way, of course, is just following this pattern. Now, again, I'm doing PDF because it wants exactly 68, okay? So that's the pattern I'm going to do. Let's go to Desmos and change some of these values, okay? So I don't want 100. I want 200 adults. So notice how my values are changing now, right? So I want 200. Now I don't want 0.67. I want 3.4. And then I don't want 75, exactly 75. I want exactly 68. So then now this is my actual probability. So 0.05946. So I'm going to go over here and I'm going to actually type it in. So 0.059 and then 46. That is my probability of selecting exactly 68 spouses who have hidden purchases from their loved ones. Okay, so that is about 6%. It's pretty dangerous, I think. I don't hide anything from my wife, as it should be, and we have a joint bank account, and so her money is my money, which is good stuff. Communication. So that is PDF. Now we're going to go into what we call CDF. Okay, and so I'm going to show you what that is now. Okay, I used to be a big video game player. Just letting you know, I don't play video games at all now. I read like a crap ton. I read all the time. Every single day I read at least five some pages of really deep philosophy, theological things. So I read a lot, and I read journals and watch videos about that, but I don't play any games. But one of the games I used to play all the time was God of War. Okay, was God of War. So, a survey of US adults found that 62% of women believe that there is a link between playing violent video games and teens exhibiting violent behavior. You randomly select 4 US women and ask them whether they believe that there is a link between playing violent video games and teens exhibiting violent behavior. Find the probability now that exactly 2 of them respond yes, and at least 2 of them respond yes, or fewer than 2 of them respond yes. So now here's what we're doing. We're actually finding 3 probabilities in one. Ready? We're finding 3 probabilities in one. We're finding exactly 2, okay, at least 2, and then fewer than 2. Okay, so we're finding all these different probabilities. So I'm actually going to color code this so it's a little bit easier. So the first one we'll do blue. Next one we'll do red. So at least 2. But I want to get a better line here because that looks like crap. So at least 2. And then I guess the next one will be purple or pinkish. Okay, fewer than 2. All right, so now in green, what's my variables? My variables here is n equals 4. Okay, why? Because you select 4 US women. Okay. My probability of success is 0.62. Gives it that to me right now. My failure is 0.38. Now notice, do we really need failure? If we're going to do it on Desmos here, do we really need the failure? No, we actually don't. Desmos calculates that for us regardless. So I really don't need the failure probability. I just need the success probability. But sometimes Math Excel will still ask you to find the failure probability. So I like to put it on there. And then, of course, I do need my x. Okay, I do need my x. Now, my x will change depending upon which probability I'm doing. Exactly 2, at least 2, or so forth. But for the first one, it is exactly 2. Okay, so I'll actually put that in blue. So my probability for the first one is exactly 2. So for the first one, I'm going to do the probability of exactly 2. What does that equal? What does that equal? Let's go to Desmos to find out. Now, when it says exactly 2, guys, remember, I'm going to be using PDF, probability density function. It's dense. I want exactly 1. One option, and that, in this case, is exactly 2 US women. So how do I do this? Well, we said my n was 4, so I'm going to change that to 4. I'm going to change my probability of success to 6.2 because that's what we wanted. And now notice how it says 0, because if there's 4 trials, how can I choose 68 out of 4? That doesn't make any sense. That means it's a null event. But if I change it to 6, it's still something, right? It's still null because 6 is greater than 4. I want exactly 2, and then boom, we have our probability. So 0.333. So I'm going to write that down here, 0.333. So that's roughly 33% of women. If I pulled from 4, if I pulled exactly 2, they would say 33% of those women would say, yes, I believe there's a link between violent video games and awful crime. Okay, and then violent behavior, like God of War, of course. That looks pretty violent. He's pulling an eyeball out. So, yeah. Okay, so let's go to 2. Now, 2. It says at least 2. What does that mean? At least 2. What that means, and I'm actually going to do an arrow here. At least 2. What that means is the same thing as this. The probability of x being greater than or equal to 2. Why? So if I say, give me at least $5, can you give me $5? Well, yeah. So probability of 2. Can I say, can you give me at least, if I say, give me at least $5, can you give me 6? Yes. Can you give me 10? Yes. Can you give me 11? Yes. Can you give me 100? Yes. Why? Because it's at least $5. the least you can do is $5. Okay? But $5 and above, which means it's at least 2. So that means I have probability of 2 plus probability of 3 plus probability of 4 here. Okay? So this is what we call right here. Okay, this is what we call the CDF calculator. Okay? This right here was called the PDF calculator, the probability density function. And then this right here is what we call the CDF calculator. It's called cumulative density function, or sometimes called cumulative distribution function. Okay, cumulative distribution function. So now what we're going to be doing is we could do this the long way, right? We could find the probability of 2 the long way, the whole formula. We could find the probability of 3, the whole formula. Probability of 4, the whole formula, right? And then I could add them all together. Why would I want to do that when I can use what we call Desmos.com? So the probability of x being greater than or equal to 2, at least 2, equals some number. Let's find out what that number is. Now, I'm not going to use the PDF right here. I'm not going to use the PDF. I'm going to be using what we call the CDF, cumulative probability. So because I want to add them, right? Cumulative means add. So I want to add these together. So now what do I have to do? Well, I have to adjust some things, of course. Clearly, this is not 11 million, right? I can't do that. So I have to change it, right? So that means I need to change it to my n, which is 4. And then I need to change this probability to 6.2. That doesn't change, right? That doesn't change. Now, what does change? What changes is this, the min and the max. Now, what's my minimum? Think. My minimum, right here, this is why I wrote it out. Follow my mouse. My minimum is what value? What is that? What number is this? What number? It's 2. Okay? What's my max? What number? What number is this? It is 4. So what's my min? 2. What's my max? 4. Okay? That's what it is. So now I'm going to go and I'm going to change this 4 to 2. And that is my probability. Okay? Now, notice this. This is a graph. We're going to get into this in a little bit. We do have a graph for this, and this is great. I'm not going to explain it too much right now, but this is our technical probability distribution. This is our probability distribution right here. Okay? I'm not going to get too much into that right now, so just hold on tight. Don't look at that. All I really care about is what it equals, and that right here, my friends, is 0.843. So I'm going to go over here and I'm going to type that in, 0.843, 0.843. Okay? That is my at least 2 probability function. That 2 of them say yes. Now, let's go to 3. So 3, fewer than 2 of them. So what is fewer than 2? So that means x is less than 2. Okay, x is less than 2. That means the probability of 0 of them plus the probability of 1. Now, why isn't it equal? Because if I say give me fewer than $5, can you give me $5? No. Okay. I would say give me at most $5, and then you can say, okay, $5 and above or below. But I'm saying fewer than $5, then that means you can only give me 4, 3, 2, 1, or you can give me $0, right? And the same thing is true here. You can, if I say less than 2 or fewer than 2, that respond yes, fewer than 2 respond yes, that means it's 0 of them can respond yes, or 1 of them can respond yes. Okay, so what is this probability? What's my minimum? 0. What's my max? 1. So I'd go over here. That doesn't change, right? That doesn't change. That's still my n. That's still my probability of success. But what does change is this. I'm going to change this to 0. Now notice right before I change my max, watch. Notice right before I change my max, this is 1, right? And if I actually plug this in, now look at all of them. They're actually all like solid, right? They're all solid, which is great, okay? And so what this means, guys, is that that's my normal that's my probability distribution. That's actually equal to 1. All the probabilities actually equal to 1. The problem is I don't want 0, 1, 2, 3, 4, right? I don't want the whole trial of women, okay? I only want 0 to 1. Okay, 0 to 1 is all I want right here. So fewer than 2 is roughly 0.157. 0.157, and that's what I do. My min, 0, my max, 1, 0.157. I go over here, 0.157. That is my answer. So this is what we call the cumulative density function or the cumulative distribution function, where we're given not just a PDF, but CDF form. And this is also a CDF, or cumulative functions, where we have to have the calculator add them together. So what the calculator is really doing, guys, is it's adding these together in one whole swoop. And we don't have to do anything. That's awesome, right? That's awesome. Okay, so let's continue. Let's go through a couple more of these examples. So this is another violent video game. Of course, this is Call of Duty. If you don't know that, then I'm sorry, but this is Call of Duty. So example 5, we found that, surveying example 5 found that 53% of men believe that there is a link between playing violent video games and teens exhibiting violent behavior. So now instead of women, we're going to men. Okay. Randomly select 5, so automatically my n is 5. Okay, my p will be 0.53, and then my x. What is my x? It will change depending on what it's asking us. So find the probability of exactly 2. So the first thing we want to find is the probability of exactly 2. That's the first step. The second thing that they want us to find is at least 2. So again, the probability of x being greater than or equal to 2. Okay, which is the same thing as saying probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. Do you want to do all that by hand? Of course not. So you're going to be using Desmos. Okay, so what does the probability of x greater than or equal to 2 actually equal? We're going to find that out. And then 3, fewer than 2 of them. So fewer than 2 is a probability of x less than 2, which is the same thing as probability of 0 plus probability of 1, and then plus, that's it. Nothing else, because it's fewer than 2, right? So this is all I have. And then we're going to have an equal. So awesome. I like to write this out because I like to show you what the mins and maxes are, especially with my CDF function, my cumulative density function right here. But in number 1, it asks us exactly 2. Am I going to use PDF or CDF? You should be saying PDF. Okay, so let's go back. Make sure you write these down, my n and my p value. My x will change. And in this case, my x will be 2. Okay, so now let's go back. Let's change this to 5. Notice how I'm on my PDF function. I changed this to 5.3. So I change this to 5.3, and then exactly 2. I already got 2. Awesome. So what's my probability? 0.2916. I'm going to go over here. So 0.2916. Sweet. That is my probability. Okay? Found it right here. Right there. That's all I need. PDF function. Boom. Okay? Awesome. Now, my second one is going to be the probability of at least 2. So that's 2, 3, 4, 5. So what's my max? 5. What's my min? It's going to be 2. So that means I need to go over here. I need to change this. I need to change these as well to 5. I need to change this as well to 5.3. And then my min is going to be 2. And then my max is going to be changed to 5. Okay, so that is going to be changed to 5. So my probability is 0.8478. I'm going to round that 7 to 8. 0.8478. So that is what I have. 0.8478. Perfect. Perfect. Now, one last one, 0 to 1. So my min is 0. My max is 1. So I'm going to change this. I'm going to change that to 1. Notice how it's giving me red because you can't go from 2 to 1 because that's not reading math left to right. So now 0 to 1, and boom, that's my answer, 0.1522. Okay, 0.1522. Guys, it is really just this easy, 0.1522. It is this easy. That's it. That's all you're really doing is plugging things into Desmos like over and over and over again. I cannot tell you how awesome. If I were you guys, like this is a great thing, like because it's just plugging stuff in. The hardest part is to find what your n value is, what your p value is, and then what this means. That's literally the hardest part. Okay. So now let's erase and let's get to actually graphing. And after graphing, we're going to go through the population, the population parameters. So mean, variance, standard deviation. So about 60% of cancer survivors are ages 65 years or older. You randomly select 6 cancer survivors. You ask them whether their age is 65 years or older. We're going to construct a probability distribution. We're going to graph it after we construct it, and we're going to see what it looks like. Now, usually you would have to do this by hand. Okay, we're not going to do it by hand. We're going to have Desmos literally do all the work. But before we actually do that, we're going to do this. Okay, so what does this mean? Well, this is a table. So this table is 0, 1, 2, 3, 4, 5, 6 because we're 6. Okay, so my n is 6. So because n equals 6, that means my x will be 0, 1, 2, all the way to 6. Okay, just like what I have here. Now, what is my probability of success? My probability of success is 0.6. Okay, that's my probability of success. So now that I got my n, now that I got my 0.6, I can go and actually start going to town on these. Okay, so let's go over here. Now to find 0, I'm going to stay on this graph. To find 0, 1, 2, 3, 4, I literally have to just keep doing this over and over and over again, which means, guys, really what I have here is PDFs. So I want to find probability of 0, probability of 1, probability of 2, probability of 3, probability of 4, probability of 5. Like that's what I want to do. Okay, so maybe I'll do this. This is probably easier. Yeah, let's do that. Okay, maybe. Is it going to, there we go. That's a little bit better. Okay, that's good enough. Awesome. Okay. I'll just move it just a tad bit. So what do I have here? Come on. Great. Okay, so now that you guys see this is a lot easier. I think it will be a lot easier for us to kind of see what's happening here. So right here, what I have is my probability density, my distribution. I want to do 0, 1, 2, 3, 4, 5, 6. I already put it in here. Probability, my n is my n is 6. My probability is 0.6. Okay, the probability is 0.6, which I already have here, and then 0. So what does that mean for us? That means I'm going to literally type in that value. Look at that value right here. That's what I'm going to type in. Okay, so this is 0.004. Okay, I go back, and all I have to do is just hit backspace, and I just plug in 1. That's all I need to do. Okay, just plug in 1. So that means my probability is this right here. So that is 0.0 and then 37. Let's round it there. Okay. I go over here. I want to do 2. And so now it's 0.138. And then I keep going. I keep going to town. So I want you to finish the rest Go ahead and plug 3 in there, finish the rest, and then pause the video and then see if we get the same answer. So go ahead, finish the rest, get 3, get 4, get 5, get 6, and see if we get the same answers. Awesome. So this is all the answers right here. Boom, 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 boom. 0.04, 0.037, 0.138, 276, 311, 187, and then 047. These are all the probabilities. Just keep going back and forth over and over and over again. Now, watch what I'm about to do here. We're going to graph this beast. Watch what I'm about to do here. I'm going to change this. So 6. I'm going to change this to 0.6. Now watch what I'm about to do. Now I did do 1. Now look at this. Look. So right here, 0 to 1. Okay, I have this. Very familiar, by the way. Very familiar to this. Now what if I did just 0, 0? What do I get? I get that. I get the exact same thing, right? Now what if I did 1, 1? Okay, so if I did 1 and then I went over here and I did 1. Okay, I would get 0.368, which is exactly what we got here. We just rounded it. So you can still use the cumulative function for the PDF, the one exact answer. You just have to adjust your min and max. But I don't want to do that. This is what I want to do. Now watch what I'm about to do. I'm going to change this from 0 to 6, just like our x values. Okay, 0 to 6. Now I'm actually going to toggle. Notice how it's 1, because it's a probability density function. It's an actual probability distribution function. Okay, it has to be 1. I'm going to plot this. Now watch what happens. Look what happens. Look at all my answers. Watch. Are all those answers, do they look familiar to you? Do they look just familiar to you at all? Okay, so look at 0. Ours was 0.04. We got right here 0.04. Okay. Okay, we got 0.04 and we got 0.04. Okay. Now right here, I got 0.369, which rounds to 0.037. That's 1. For 2, I got 0.1382. We round it to 0.138. You see the pattern here? All you had to do is just select the CDF, and I'll show you what that is again. All you had to do is just select the CDF right here, go from 0 to 6, graph it, zoom up a little bit, and then move over. And then boom, you have all your answers right there. You could have just done that from the very beginning. That's cool. Okay, that's cool. I mean, literally, it gives you the answers. That's awesome. Okay, it helps you, right? It's so cool. And so please use that opportunity, use this function whenever it says, graph the function. You can just graph it right here and then look on Desmos. Okay, what does it look like? Okay, where's my probabilities at? Because remember, what you plugged in was X. What you get out is your probability. And that's why you have these points. What you plugged in was 2. What you got out was your probability. That's domain and range. Okay, what you learned in Algebra 2. Sweet. So I'm actually going to stay like this in the screen because I think this is beneficial. So I'm going to go back over here, erase this. And now what we're going to be learning is this. So the mean. So the mean, variance, and standard deviation. What is the mean, variance, and standard deviation? They're really short formulas that you honestly could do by yourself. I mean, you don't really need Desmos to do it for you, but we will be using Desmos. Your mean is literally just your n times your p. Okay, very short formula. I mean, awesome. You can definitely do that just straight up out of the market. Variance is sigma squared. That's what that O is, sigma squared, and then n times p times q. And then your standard deviation is literally the exact same thing, but it's the square root of n times p times q. Awesome. So that's all it is. Now, we could do this all by hand because if I am given an example like this, I could do this all by hand. Pittsburgh, Pennsylvania, about 56% of the days are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days, and then interpret results. Okay, so first of all, what's my n? Well, how many days are in June, right? June, yep, the month of June. Well, there's 30 days. And then my probability of success for it being cloudy is 0.56. So what does that mean? That means I'm literally now going to go over here and I'm actually going to adjust it. Now watch what happens. Okay, adjust this. Okay, I want from 0 to 30. Okay, 0 to 30. Now I'm going to adjust my days, so 30. I'm going to go over here and I'm going to adjust my probability to be 5.6. Now look what happened, guys. Seriously, look at this. This is your mean. This is your variance. And this is your standard deviation. Done. You don't even need to multiply anything together. You literally just click on a few keys. That is it. You click on a few keys. I already calculated it for you via Desmos. Okay? That simple. Okay, so that's what you will be writing down. You will literally be writing down this for your mean. This is your mu. This right here is your variance. And this right here, rounded a couple of spots, is your sigma, your standard deviation. Done. You're welcome. That simple. I promise. Okay? To me, there's no excuse. We should not be failing statistics when it's literally this easy. This easy. This easy. You're just plugging things in. You're literally just typing things. You're typing numbers. Okay? And then you're getting answers. That's all you're doing. You don't even really need to think. Wow. Look at that, math class. All right? So please take notes on this. Make sure you understand how to use Desmos. If you don't know how to use Desmos, it's going to be a very difficult time for you. I promise. Okay, you need to make sure you know how to use Desmos.com. So, what did we learn? We learned a lot of things. We learned how to interpret the probability, but more than that, determine the probability experiment and whether or not it is a binomial experiment. We found binomial probabilities using the binomial probability formula the long way. And then we found probabilities using technology, the easy way, using a formula, which we did, and then the binomial table, which then I showed you on the graph, which is easier. Then we constructed and graphed a binomial distribution and then found the mean and variance of the standard deviation. We did all of that in a short period of time. Guys, I hope you paid attention. I hope you are getting familiar with Desmos and this function, this graph, and I hope you are adequately prepared for the homework quiz tomorrow. So please, please, please do your homework. Do it. If you get 100% on the homework, you get up to 2 extra credit points on the homework quiz. If you have any questions, please email me. Okay, please email me if you have any questions on Desmos or any other helpful tips that you could probably share my way to make it better. Let me know. This is C Squared Mathematics. Please be sure to like and subscribe. See ya.